In this demo, we refer to a production process based on the additive manufacturing. Peculiarity of this technology is that to get the desired shape, the material powder is added instead of being removed, as happens in the subtractive metal cutting based on milling and drilling. This allows to overcome the cutter's access limitations and makes possible to realize organic geometries. The resulting parts are lighter and stronger since we reduce the need for assembly. The UADM solution includes functionalities that can support all of the configuration, execution, and collateral processes concerning additive manufacturing that are visible in the reference process. First of all, the entities must be modeled: the 3D printer, the substrate, the powder materials, the print job file, and eventually the manufacturing process that defines the relation between the previously modeled objects by specifying when and where they must be used and how they are equipped with work instructions. Once everything is modeled, the work order execution based on the defined process drives operator on the manufacturing operations and collects point of usage of the resources, process parameters, and execution times. When the manufacturing is over, the additive manufacturing collateral processes are supporting the maintenance operations. To recycle the remaining powder, mix it with other batches in order to get the proper capacity ready for further printing, and prepare the substrate for a new printing job. The process engineer, responsible for modeling the production prerequisites, can define a new 3D printer by adding it to the company's plant model. The machine definition attribute identifies it as an equipment suitable for additive manufacturing. Then it is time for defining the product that will be realized. It's defined in the materials page, and it is not necessary to specify here that it will be realized with 3D printing. The idea is that you can get it done anyhow. Only the process is establishing in a second time how to realize it. For products that are realized over a reusable flat metal shape, we can define the substrate. A dedicated set of priorities such as the thickness and the thickness decrease for every maintenance cycle can be set here. Once the substrate definition is complete, the engineer can list all the existing instances of the same part that are available in the plant. Of course, they inherit all the properties previously specified. Next step is to define the raw material powder that will be melted over the substrate to shape the product. In this case, the material class is set as AM powder. This particular class of materials is characterized by specific attributes, such as the maximum recycle count. This parameter indicates the maximum number of time, and the powder can be reused after it has been inserted in the 3D printer. It is also possible to associate a predefined template for this material definition so that each specific instance of the material inserted in the system will follow the proper naming convention. And then, according to the purchased powder batches, the warehouse supervisor can define each single powder batch they are working with, indicating the specific quantity. And here too, the powder definition properties are inherited. Once the design department finalized the program to instruct the 3D printer which movements are needed to realize the product, the print job file can also be modeled, and here it is important that it refers to the realization of a specific product with a specific 3D printer. Once the print job file is here configured, it will be managed by the system behind the scenes. Now that all the basic components are defined, the process engineer can proceed to design the manufacturing process. This includes all operations meaningful in the production environment, so it is not limited to the 3D printing itself. There will be at least one operation dedicated to set up the 3D printer, where it is important to specify which is the printer and what powder and substrate to load. The engineer will also be able to specify the amount of material needed and attach the work instructions and data collection forms. Let's move to the shop floor, where after receiving a production request, a production order is available for the operator. Here, He can track when he is attending the manufacturing operation, and he can review the work instructions and fill in the traceability details. The powder batch label and the substrate label. He can also rely on the system to ensure that the proper print job file is loaded into the 3D printer. This avoids manual setup and time loss in validating the program validity. Another operator will then take care of removing the residual powder from the printing cell. He can track in the system the quantity and mix it with other powder batches to be returned to the warehouse. The system has the responsibility to keep track of this information to support a transparent genealogy that will drive the evaluation of the validity of usage of the resulting batches. Powder can be recycled up to a certain amount of times before being unusable for printing to guarantee the raw material quality. In the warehouse, the received residual powder can be mixed to compose new batches ready for other printing jobs. The system has the responsibility to keep track of the mixing information to support a transparent genealogy that will drive the evaluation of the validity of usage of the resulting batches. When two different batches are mixed, the new batch that is created will inherit the higher recycle count in order to fulfill the best quality standards. The supervisor needs to verify the occurred mixing of a batch, and the system shows all the historical batch labels. When they were mixed, which was the quantity and the operator in charge. Another operator has the responsibility to prepare the substrate for a new printing operation. Typically, he's chemically threatening the item and even cutting it. The results is that the substrate thickness is reduced, so it is important to track the current measures. Now we are ready for a new production. We tracked everything, and we are sure that we will produce in time and with quality.